battery breakthrough, powering the future.
Energy is going to be important part of everything we do as we move into the abundant future. We'll probably be using more electricity, as much as double in the next 30 years. Where's that going to come from? Is that going to be the electricity we've been getting? Or do we need to get a little bit more picky about the sources of that power? And if we can use sun, solar power, and wind, we'd be getting that in the way we've been getting it, which is only when the wind's blowing or only when the sun is up? Or are there ways to store that and do better? So batteries are an ultra important part of this. And I want to talk to you about some stuff I've learned about batteries that I think is going to make smooth out a whole lot of this, and in some cases maybe make the power that we use a lot better. First of all, to me, a battery is anything that stores the power. In some cases, they're using solar. Actually, I think my house gets this power. It's here in Las Vegas, and a lot of the homes are hooked up to the grid in such a way. It's the grid, so all the power kind of gets mixes together. But we do have coal power, and we do have old ways of doing. We have hydropower from the Hoover Dam that we really don't get much of. That's mostly for California. And but point is, there's this great thing that you see when you drive to California out in the desert, where you see a lot of mirrors pointed at a tower. And I think there's three of them on that one. And you can see what's going on, and it's the solar is not collecting in the converting to electricity. They're aiming all of this with mirrors at these towers. And so I had to investigate, and I found out there's two of them. The other one is in Nevada. It's 50 or 75 miles from us. It is supplying power to the Las Vegas metro area. And so as I discovered, what's happening is the sun hits the mirrors. They're aimed at the tower where there is salt, and the salt is melted, molten salt. And yes, everything melts at a certain temperature. Salt is fairly hot, also retains the heat. And so they put some kind of system to get it up in the tower and then back down. And then the heat coming off of that molten salt causes a boiler to work and generates power. In fact, a lot of the power we get comes from there's something being heated up, and there being some kind of generator that turns, and that makes the power go. Whether or not you're burning coal or using solar power, those work somewhat the same way. So that's one kind of battery. Salt can be a battery. And then of course the other one that I really like is when they find out when their power is plentiful, they pump water up into a reservoir, and then when the power is needed, that water is let out, and by gravity falls through the wheels and mechanisms and whatnot, and then generates the power there. Instead of having to have the steam involved, it actually is just completely reusable, just water falling. And then at the bottom, they can pump it back up to the top when there's excess energy, so that, say, with solar power, you would have power at night that way. So those are great. But most of us, the batteries that we know about and use all the time today are primarily lithium ion, which is a battery that comes from a really smart guy. I studied him a little bit, and if you want, go find that guy. It's easy to find. His name is John Goodenough, and I guess he could have had another name, but that one was good enough. Okay, that's the stupid pun. Hopefully, you'll remember his name that way. He won Nobel Prizes for things he made to miniaturize and make for better power and things like that, like work he did back in the 70s. And that gave us lithium ion. And then some other compounds he's worked on. And in the last 20, 30 years, he's working on one. He's 90 something and still in the lab every day working on stuff, other things that they can do like that. EVs, electric vehicles, have been using lithium ion batteries and packing more and more juice into smaller and smaller space. So the batteries we're getting today, the reason why your cell phone charge will last a whole day or 2 days is partially because they've managed to make them bigger. In some cases, I have the biggest phone I can get because it makes me able to read it. but also it makes for a larger battery, and that battery just lasts better. And all the circuits running off of it, they've optimized to make it work better. So everything works better and better all the time. And that's going to continue on. One of the limitations to that is the supply of lithium. And lithium has to be mined. It comes out, it's very plentiful in various places. And then it has to go through processes that aren't as bad as some of the other mining processes you hear about, but are still more work than and more environmental concern than if you were just able to scoop it up and use it. And so one of the problems was whether or not there was enough. Since I've been studying lithium, the amount of lithium that they've discovered has skyrocketed. It used to be there are several places where the lithium comes from, and now it's every country has lithium mines at this point. So there's a lot of lithium around. That's not the problem. The other problem with lithium ion is those ions. The way that part of it works, in every battery, you have to have an anode and a cathode, or a plus and minus. Plus and minus is what we call them. Anode and cathode is what the technical terms are. So I'm just going to say plus and minus. So you get the lithium on one side, and then whatever else goes with it on the other side. And there's various things, and they keep improving them to make the batteries last longer. And so what happens is ions will move from one side to the other side, and there has to be something in between, usually some sort of a gel, whether or not that's in a battery, that little battery you put in electronic equipment, all the way up to cars. It's the same kind of things. And even when it gets to be batteries that are like size of a container and can store power for the power grid, they still basically have the same sort of process of the charge moves from one side to the other. And as it discharges, it moves back. What happens with lithium is that it goes through that substance, and some of the lithium leaks out, and it's almost like building stagnant the things in caves that hang down from the mineral deposits. You get little things jutting out from the side of the lithium towards the other side. If it ever reaches over the gap,